students of class 11. Hope you are studying properly. Already we had done the chapter Biosphere from my part, and in this video I will start the chapter that is the earthquake. This chapter. So earthquake. First we have to know the definition of earthquake. Earthquake means the tremor or shaking of the earth. Earthquake means the tremor or shaking of the earth. The sudden jerk that is felt and that causes tremendous movement in the earth's crust is called earthquake. So what is the definition given? An earthquake is a shaking of the crust of the earth. It is a sudden jerk or movement or shock or tremor of the earth's crust which originate naturally beneath the earth's surface. So any tremor or shaking or jerk that originate beneath the earth's surface that causes huge destruction of life and property is called earthquake. This is the definition. Then next is center and epicenter. Center or focus and epicenter. Let's first draw a diagram. This is the surface of the earth and this is the center. The point this is the surface and this is beneath the earth's surface, that is at the interior of the earth. The place where earthquake originate beneath the center of the earth is called earthquake, and the point that lie perpendicularly or vertically above the center of the earth on the surface is called epicenter, where the intensity is maximum. So what is center? The point where the earthquake originate is called the center, and the point that lie perpendicularly or vertically above the center where the intensity is maximum is called epicenter. So this definition along with the diagram you have to read. Next, the types of seismic waves. Now see, the earthquake originates here at the center and it have to reach on the surface of the earth, and there earthquake is actually what? In the form of energy. At the center energy is generated and from there the energy is released on the surface of the earth, and the energy is released in the form of waves. From the center the waves reach the surface of the earth. Okay. So accordingly the earthquake waves are of three types. One is P wave, one is S wave, another is L wave. These are the three types of earthquake waves or seismic waves. They are also called seismic waves. So first is the primary wave. The wave that reach on the surface first is called primary wave. The intensity of primary wave is 5 to 14 km per second, and they move to and fro direction. Means to and fro means coming and going. In this way it is moving on. Next is the secondary wave. It comes just after the primary wave. Its magnitude is 3.5 to 7.2 km per second. It passes deeper the earth, and L wave that move on the surface of the earth. L waves, the full form of L wave is long wave. It is also called love wave. And you know that which seismic wave is very much destructive? The L wave is very much destructive seismic wave. Very important. The L wave is very destructive seismic wave. Now, see, one chart is there in your book there is one chart. This chart is very important. Here in this chart, a comparative view of the three seismic waves has been given. A comparative view. So first, the primary wave. The primary wave comes first on the surface of the earth, so it is called primary wave. Next to primary wave is the secondary wave, and the long wave reaches at last, but it is very much destructive. Point number 2 is very important. The wavelength of the primary wave is short, medium for secondary wave, and longest for long wave. Third, as the primary wave proceeds, it strikes parallel to the direction. Secondary wave right angle and long wave obliquely. Fourth point, very important. Primary wave can pass through solid, liquid and gaseous. Secondary wave underline only solid and long wave only solid. So, this is very important for MCQ. Then the velocity is given 5 to 14, 3.5 to 7.2 and it is about 3 to 5. The other name of primary wave is sudden jerk or push wave. Secondary wave, it is called shaking wave. And for long wave, you know that L wave or love wave. These are the other names. Clear up to this? The next part is the shadow zone. What is shadow zone? What is shadow zone? Shadow zone are the areas on the earth where earthquake waves do not reach. Only the definition, where the earthquake waves cannot reach, it is called the shadow zone. At what angle? Only this part you will read. 105 degree and 145 degree. These degree areas are considered as shadow zone where earthquake waves cannot reach properly. Okay. So, first 2 pages, mark what you have to read. The definitions of earthquake, seismic wave, what is focus, what is epicenter, diagram, the 3 primary waves, secondary waves, long wave, comparative view, and the shadow zone definition. Now go to the next page. Now go to the definition. So, the next page, go to next page. There are 3 scales, instruments, seismograph, Mercalli scale and Richter scale, which are used to measure the intensity of earthquake. Seismograph is an instrument by which underlying the earthquake shocks are recorded. See the picture. In this instrument, a pen is recorded by tracing up on a revolving drum where a graph has been attached, and when there is any shock, the these drums start moving, and the pen used to draw scales or means mark on the graph paper attached there, and accordingly the intensity is measured. Then Mercalli scale. Mercalli scale is used to measure the intensity of earthquake. It is not used nowadays. It is a scale ranging from Roman 1 to Roman 12. When it is Roman 1, it is not felt properly. And if it is Roman 12, it is very much destructive. Next, the Richter scale. Richter scale is a device which was invented by an American seismologist, Richter, the American seismologist Professor Richter. In this scale, it's used to measure underline the intensity of earthquake. Richter scale is a scale ranging from 0 to 1. It is logarithmic. Logarithmic means when the intensity increases, suppose 1 to 0 to 10. Then 1, 2, 3, 4, 5, 1, 2, 3. When the intensity increases, it increases 10 times. 2 to 3, intensity increases 10 times. 3 to 4, intensity increases 10 times. So, the intensity increases or multiplied by 10. So, it is the most important and useful device to measure the intensity of earthquake. When on Richter scale, if it is 2, the earthquake just fell. If it is 6, building can be collapsed, and if it is 8.7 or 9, tremendous destruction occurs. Okay. Now, the next part, isoseismal line and homoseismal line. Isoseismal line are the lines that are joining places having equal intensity of earthquake. Suppose 6 in place A6, place B6, place C6, these 4 or 5 places records 6 intensity of earthquake. And if we draw an imaginary line to connect these places, that is called isoseismal line. And what are homoseismal line? Homoseismal line means the line which the places which receive earthquake at the same time. And if we join the places with an imaginary line where the earthquake intensity is experienced in same time, it is called homoseismal line. And then the last part of this last section of this part, that is the isoseismal and homoseismal definition or difference. So first difference, it indicates line places equal intensity and experience same time. For this line, we have to take places which have almost same intensity and same earthquake, and the definition and examples. So 3 pages that we had done in the first part. You should go through this part only from the first part. All the short questions and means brief type of answers you can get. Okay. Thank you, and we will continue the next part in the next video. Thank you.